So let's look at our first question. We're going to calculate missing sides using our trigonometry ratios. First and foremost though, you're going to have to get good at labelling triangles, because it's by labelling the triangle that you decide which of the ratios that you're going to use to help you do this question. So, first and foremost, you go to the angle. The angle this time isn't 45 degrees, it's 50 degrees. But you label from the angle that you've been given, which is the 50 degrees. Remember the one that I always label first is the hypotenuse. The hypotenuse is the one always opposite that right angle. So this one is called the hypotenuse. So I'm just abbreviating it to HYP. Okay, I then go to my angle and I go to the side that is opposite the angle. So the letter X, the side that I'm trying to calculate, is the side that is opposite the angle. Finally, got nothing else left to go other than the adjacent, which is the one which is next door to the angle. Now, let's remind ourselves of our ratios. So, ca, toa. Sine ratio, opposite over hypotenuse. Cosine ratio, adjacent over hypotenuse. Tangent ratio, opposite over adjacent. So that's how we remember the ratios. S, C and T are the sine, the cosine and the tan. And then these are the sides. Opposite over hypotenuse for sine, cosine adjacent over hypotenuse, tangent opposite over adjacent. Let's go back to this question. We know the sine of 50, the cosine of 50, the tan of 50. How do we know those answers? Well, literally, we could type into our calculator sine of 50 degrees, cosine of 50 degrees, tangent of 50 degrees, and out comes a number. That number is the ratio of these sides. They're different for the sine, the cosine, and the tangent because they're different lengths. But for this right angle triangle, we have to determine which of those ratios we're going to use to calculate that missing side. Well, first and foremost, if that is the missing side, and I've labelled it the opposite, the ratio must have the opposite side in. Look at these ratios here. One of these ratios does not have the opposite side in, so it would be a complete waste of time using it because it's not going to give me the missing side. Which one? This one. Cosine doesn't have the opposite side in it. It's the adjacent and the hypotenuse side, so I'm definitely not going to be using that one. It's got a choice now between the sine ratio or the tangent ratio. Well, I've got to use the other side. The other side is the side that I'm given. I've been told that the hypotenuse is 8 centimetres. If I use this side, I haven't got it. I haven't got the side that I'm looking for. In fact, I've got no information whatsoever if I use the opposite and the adjacent. So I must be using the opposite side and the hypotenuse side. I go to my ratio and determine which one that is. That is the sine ratio. So I'm going to do this question using the sine ratio. And what do I know? Is I know the sine of 50 on any triangle, right angle triangle in the entire world. If you divide the opposite side by the hypotenuse side, you get 0.7660. I guarantee it. It's for anything. Any size right angle triangle, with that being 50 degrees, that side divided by that side is 0.7660. And that's really useful to do this question. Just watch. I'm going to set it up. Sine of 50 degrees equals opposite side over the hypotenuse side. Okay. But I know that. So long as I've only got one thing missing here, I can solve this equation really quickly. It won't take hardly any time at all. So let's put my lengths in. The opposite side is x. That's the side that I'm trying to calculate or find. The hypotenuse side is 8 centimetres because the original question tells me it's 8 centimetres. And the sine of 50 I can get straight from my calculator. Obviously you'll need a scientific calculator, but you press the sine of 50 right now on that scientific calculator and I guarantee out comes 0.7660. If it doesn't, okay, the chances are you're not in degrees. So just change your scientific calculator to degrees. Okay, little d will appear on the display. So how am I going to find that missing letter? Well, it's a mini equation. This, remember how we solve equations? When I get rid of that divide by 8, because it's on the same side. How do I get rid of divide by 8? I times by 8. So it's 8 times the sine of 50 is equal to that missing side. So it's 8 times 0.7660. Type it into your calculator and to one decimal place it comes to 6.1 centimetres. So you found your first missing side using trigonometry. Let's have a go at calculating this missing side from this right angle triangle. Key factor, trigonometry, make sure that you label your triangle correctly because that leads you to use the right ratio. Which one do I always label first? The one opposite that right angle, which we now know is the hypotenuse side. I then go to the angle I've got. Notice the angle I've got this time isn't the one down here, it's the one here. What do? I label the side that is opposite the angle. This is the side that is opposite that angle. Then I've only got one side left to label, and that's the one that's next door, and the one that's next door is called the adjacent side. Right, so let's remind ourselves of our ratios. Sine is opposite over hypotenuse. So, cosine, adjacent over hypotenuse, ca. TOA, tangent ratio, opposite over adjacent. Got to make a decision which ratio to use. Well, one of those ratios you can get rid of straight away. One of those ratios has not got the adjacent side in, and you're asked to find the adjacent side, so we can put a line through that one straight away. It's definitely not going to be the sine ratio because it hasn't got the adjacent side. What's the next bit of information? We've got to use the side that we've got. The side that we've got is the hypotenuse side. It is 12 centimetres. I'm trying to find the adjacent side, which is x. So my ratio is the adjacent and the hypotenuse. So it's the cosine ratio. And what's wonderful is that scientific calculator of yours knows exactly what the cosine is of 40 degrees. You just type in cosine of 40 degrees and it gives you the exact answer for that side divided by that side in any right angle triangle, okay, in the entire world. Because the ratio is exactly the same. Given that's 90 degrees, given that angle in there is 40 degrees, any of these two sides divided together will give you that same answer that calculator gives you. So let's set it up. Cosine, we tend to call cos. So cos of 40 degrees is equal to the adjacent side over the hypotenuse side. So the cos of 40 is the adjacent over the hypotenuse. My adjacent side is the bit that's missing, so I'm going to label that as x. My hypotenuse side is 12. How do I solve that equation? All I've got to do is get rid of that divide by 12. So literally, how do we get rid of divide by 12? We times by 12. So we type into our calculator 12 times the cos of 40 degrees, and that gives us an answer, okay, of 9.2 centimetres. The original measurement was in centimetres, and I've rounded that off to one decimal place. So remember the key thing, choosing the right ratio. Because if you look at this part of it, solving it, fairly straightforward. Your calculator does the job for you. So let's look at this calculate missing side question. First thing I'm going to do now, and you should be beginning to get confident at doing this now, is labelling that triangle correctly. Remember, first side that I always label, hypotenuse side. That's the hypotenuse side. Why? It's directly opposite the right angle. What do I label next? I label the angle, from the angle, the side that is opposite that. There's my angle. I haven't got any other angle, okay, other than the 90-degree one. And I go opposite that. So that is the opposite side. What am I now left with? Is this side here. Is the side that's next to the angle. So we call that the adjacent side. Right, ratios. Let's remind ourselves what we got. So, ca, toa. we have got to choose the correct ratio. What's it got to have? It's got to have the bit that I'm calculating. So it must have the opposite ratio in. But it's also got to have the side that I'm given. So it's got to have the adjacent side in as well. Only one of those ratios has the opposite side that I'm trying to calculate and the adjacent side that I've been given in the question. It's not that, it's not that. It's the tangent ratio. So what have we got? We've got the tan of 35 degrees is equal to the ratio opposite over adjacent. Opposite side is x. Adjacent side is 12 centimetres. And this time it's equal to the tan of 35 degrees. How do I now get rid of divide by 12? I times by 12. So 12 times the tan of 35 degrees gives me my missing side. Type that into your calculator. It comes to 8.4 to 1 decimal place. And you have calculated the opposite side using the tangent ratio. You should now feel comfortable with calculating missing sides. What we are now going to do is not only does trigonometry allow us to calculate missing sides, it allows us to also calculate missing angles. And that's what we're going to have a look at next. Okay, now what we're going to do now is just going to finish this lesson on trigonometry by looking at slightly harder missing sides to calculate. So let's remember our technique. What's the first thing we must do is label from the angle that we're given. This time we're given this as 40 degrees. So remember, the first one I label is I go to where the right angle is, I go opposite the right angle and I'll label it as the hypotenuse side. Then go opposite the angle I'm given, so this side here is the opposite side, and then this 12 centimetres is the adjacent side. Remember our ratio, so, ca, so. Which of the ratios am I going to use? Well, it's got to have the side that I'm trying to calculate, so it's got to have the hypotenuse, but it's also got to have the side that I've got. The side that I've got is that 12 centimetres, the adjacent. Which of the ratios then has got the adjacent and the hypotenuse? Cosine ratio. Just see what happens then when we set this one up. We have got the cos of 40 is equal to adjacent over hypotenuse. The adjacent side is 12, the hypotenuse side is x. Notice what's happening this time. When I place that in, because remember I can't change my ratio, what do you notice about the missing letter this time? The missing side is on the denominator, it's not on the numerator. On those previous 3 questions when we looked at missing sides, it was on the numerator. Now it's on the denominator. But from the work that we've been doing on solving equations, we should feel relatively comfortable with being able to find that missing letter. How do we do it? Well, basically, we don't want it to be on the denominator. We want to bring it to the top. We want to solve an equation with it being on the top. How do I do that? Well, if I multiply both sides by x, that x will disappear, but it appears here. Okay, so that's x times the cos of 40 is equal to 12. How do I now get rid of the cos of 40, because the 12's out the way already, is I must divide by the cos of 40. So x equals 12 divided by the cos of 40 degrees. When you type that into your calculator, you get an answer of 15.7 centimetres. So, if I just go back to that part of the equation there, what you're really doing at this particular stage is you're taking the variable and bringing it here, but you're then taking the cos 40 and bringing it down there. They're switching. Okay? The reason they're switching is you're timesing both sides of the equation by x to bring the x up here, and then you're dividing by cos 40 to remove the cos 40. But if you're happy, you can just say to yourself, x comes up there, cos of 40 has gone down there, and I've been able to solve and find that missing side. Let's do it again for this one. Okay? First thing I'm going to do is, where's the right angle? Here's my right angle. I'm going to label that triangle. This is the hypotenuse, because that is the side that's opposite the right angle. I then label the side that's opposite the angle that I'm given, and that leaves me with the adjacent side here. Ratio, choosing the right ratio. Which ratio am I going to choose? Well, it's got to have the side that I want to calculate, which is the adjacent. It's got to have the side that I'm given, which is the opposite side, because that's the 5.3 centimetres. I go to my ratios, SOHCAHTOA. It's the tan ratio this time. It's got everything I need. It's got the opposite side, and it's got the side that I want, the adjacent. Here I go, setting it up. I've got the tan of 27 degrees equals opposite over adjacent. I now put the opposite side in. The opposite side is 5.3. The adjacent side is x. What do we notice this time? Is the variable again is on the bottom. If the variable is on the bottom, we've got to bring it to the top. So we multiply both sides by x. Then when I've multiplied both sides by x, I've then got to divide by the tan of 27. Quick way of doing it, x comes to the top, tan 27 goes underneath. So I'm left with x equals 5.3 divided by the tan of 27. Type that into your calculator and you get an answer of 10.4 centimetres. So, to summarise missing sides, once you've chosen your correct ratio, is your variable on the top or on the bottom? If the variable's on the top, it's nice and straightforward. We just multiply by the number. If the variable is on the bottom, okay, we just have to do a switch. Tan 27 comes down there, the x goes to the top. You now should feel really confident with two things: calculating missing sides using trigonometry, calculating missing angles using trigonometry. Thank you.